Yes.
Okay. We will solve 1, 2 numericals. So that these are introductory numericals. However, these are very important numericals from examination point of view. Okay. Let me give you a question. Are you ready?
Yes, sir.
So write down the question first and then try to solve this question by yourself. Then we will solve it. Then I will try to solve this for you. So the question is, if the reaction is given, I think those people are not coming. We are already 12 minutes late. So the reaction, if the reaction is this, the rate of formation is given. The rate of formation NO is 6 gram per minute. Calculate rate of disappearance. So which will disappear, reactants or products?
Products.
Product will disappear. No, product will appear now since they are forming, so they will appear and the reactants will disappear, right?
Yes, sir.
Disappearance of NO2. So find this out. Let me know what would the answer. Mamuna, have you understood the question?
Yes, sir.
So the reaction equation is given. The rate of formation of NO is given. You have to find the rate of formation of NO2. So you both of you understood the question, right?
Yes, sir.
Okay. Just tell me what would be the first step to solve this question. Just tell me, you may be wrong. It's there is no issue because this is a first class only and you have solved 1, 2 numericals only. No problem.
The ROC of NO2
ROC.
of
Acha,
NO2.
no, first you have to balance the equation. Otherwise, you will get the answer, but the answer will be wrong. Are you getting me? Because it is dependent on stoichiometric coefficient, na? That is why. Okay.
Yes, sir.
Like in every chapter of physical chemistry, nearly every chapter. Let me think. You have to balance the reaction. Then only you can proceed. So since physical chemistry is quantitative analysis of reaction, so the quantity should be balanced. So how we will balance this equation?
It will become 2 NO2 in reactants and 2 NO in products.
Good. So the equation is balanced now. Now solve the question. Solve it by yourself. Or sir named it as rate of disappearance and rate of appearance, or rate of disappearance and rate of formation.
Rate of consumption for
Consumption.
disappearance.
Okay, and rate of formation.
Rate of formation and rate of reaction.
Okay. You got the answer? Anyone?
No, sir.
Uh, I will change the question. First tell me where you have reached, means in what process you are in, or what you are calculating.
So is it 6
6 what? 6 gram per minute.
rate of reaction?
Rate of okay, and Mamuna, anything?
Sir, is it 12 gram per minute?
12 gram per minute. No. Let's see. If the question, since this question is a little tricky, I'm just modifying this question. If you can understand what I'm doing, you can tell me. The question is 6 mole, given 6 mole per minute. Okay. And you have to find NO2 in mole per minute. So who has got the answer? 6.
I did so.
What was your name?
Zana.
Zana. So your and your answer was
6 gram per mole.
Mamuna, what was your answer?
12.
See, actually, na, if see, was Zaina's done wrong? That she thought the question was given in mole per minute, because all the calculation we do here is in moles. How? Uh, you are in class 12th now. Have you remembered from class 11th stoichiometric coefficient that the mole consumed are equivalent stoichiometrically, right? Do you remember?
Yeah.
See, let me give you an example. You will understand it very, properly. N2 plus H2 gives 2NH3. You will. So this is balanced chemical equation, right? Can you see my screen?
Yes, sir.
Ha. So N2 plus 3H2 gives 2NH3. So the balance, this chemical equation is balanced. So what we know, that 1 mole of N2 is making 2 mole of NH3, right? 1 mole of NH3 is giving 2 mole of NH3. Or you can say 1 mole of H2 is making 2 by 3 mole of NH3, right? So the ratio in moles are same, right? Are
Yes,
you
sir.
understanding that one molecule of, let's say like 1 molecule of N2 is giving 2 molecule of ammonia. 3 molecule of hydrogen is giving rise to 2 molecule of ammonia, right?
Yes, sir.
Yeah, you can also say that 4 molecule of ammonia is made from 6 molecule of hydrogen and 2 molecule of nitrogen, right? So the ratio is same in moles. Yes or no?
Yes, sir.
Yes.
No, you can say, if you are having doubt, you can say, like for example, I'm changing the question, that 4 mole of nitrogen. Tell me how much ammonia is being produced. Mamuna, you tell. 4 mole of nitrogen will give how much mole of ammonia?
8.
8 mole of ammonia, right? Good. Correct. Now, this Zaina, you tell me. Uh, we have 12 mole of hydrogen with us. Okay. Now you have to tell me mole of nitrogen used. Mole of nitrogen used.
6.
What you were saying?
6.
6. See, we have to write like this, that 3 mole of H2 is using 1 mole of N2. Okay. So in the question, so question is 12. So 1 mole of H2 will give 1 by 3 mole of N2, right? So 12 mole of H2 will give 1 by 3 into 12 mole of nitrogen, right? So finally 4 mole of 4 mole of nitrogen is being used. Have you understood the concept? This unitary method, that 3 mole is using 1 mole of nitrogen. So 1 mole is using 1 by 3 mole of nitrogen. So 12 mole will use 4 mole of nitrogen. Okay.
Yes, sir.
Have you understood this unitary method?
Yes, sir.
Yes.
This is an old method, but this is very, it solves this question every time. Okay. So the mole are being used. Can anybody say, tell me that 1 gram of nitrogen is reacting with 3 gram of hydrogen? Tell me, is this statement correct or wrong? 1 gram of nitrogen is using 3 gram of hydrogen. Is this correct statement?
Yes.
Uh, you tell me. Memuna?
Yes, sir.
So this statement is also correct, and this statement will be also correct, that 1 mole of nitrogen is reacting with 1 mole of, sorry, 3, this is 3 mole of hydrogen. So according to you two, these both statements are correct. Hmm?
The first statement is correct.
And the second one? Can you point out the problem?
In gram, they're talking about the weight of the compound.
Mm-hmm.
And in first, we have moles.
Yeah.
They're not the same thing.
They are not the same thing. So actually, this point you have to keep in mind, that the in the reaction, the reactants are reacting and the products are forming. We will always talk in terms of moles, right? Because mole will denote the Avogadro's number of that atoms or then that molecules. The weight of that substance is not significant here. So the second statement is incorrect. If you have some problem, let me explain this also. See, first of all, this is wrong and this is correct. See, if anybody is saying 1 gram of nitrogen is reacting with 3 gram of hydrogen, how this is incorrect? Acha, first statement is correct according to Maimuna, according to you. First statement is correct.
Yes, sir. The second
Okay.
one is wrong.
So according to first statement, this is correct. So 1 mole of nitrogen means 1 mole of N2, how much gram? 28 gram, right?
Yes, sir.
28 gram of nitrogen is reacting with 3 mole of H2. H2 mass is 2, 2 3 is 6, 6 gram of hydrogen, right?
Yes, sir.
So this statement is fully correct, because this we have deduce it from this mole thing, right?
Yes, sir.
So I think you have understood that how 28 gram of nitrogen is reacting with 6 gram of hydrogen. Mamuna, have you understood?
Yes, sir.
Good. So always keep in your mind that we have to go through moles, not through mass. And you can also see, if you will carefully observe, that actually 1 gram of nitrogen is reacting with 6 upon 28 gram of hydrogen. Are you getting this?
Yes,
Yes,
sir.
sir.
So I hope you have understood this. Okay.
Yes, sir.
ठीक है. In this equation, in this question, we shall come to our question, real question. That since this is talking with respect to moles, so Zana has took out the answer in terms of this only. So her answer was 6 mole per minute, which was correct if the question would be in mole per minute. Okay. but the question is in gram per minute, right?
Yes, sir.
This is gram per minute, and you have to find the answer also in gram per minute. So I would request you to first convert this 6 gram into moles. Okay, so you will get moles per minute. Okay, and then you will get do you know how to take out moles of it? What is NO molecular mass? Anybody? What is H2O's molecular mass? Do you remember how to take out
18
mole?
grams.
Huh?
18 grams.
18 grams. So what is this molecular mass? NO's. Maimuna, you remember the formula how to take out molar mass?
No, sir.
Okay, no
So
problem.
16 grams.
16. C. Nitrogen plus oxygen. Nitrogen atomic mass is nitrogen atomic mass.
7.
No, 7 is atomic number. Atomic mass is 14. Okay.
14 plus
Oxygen is
8.
8 is atomic mass.
16.
So 30 is the molecular mass. Okay. So I think you both have remembered how to take out molecular mass of any substance, right? Do you
Yes, sir.
remember, Mamuna?
Yes, sir.
Can you tell me the molecular mass of CO2, Mamuna? Carbon atomic mass, I will help you, don't worry. Carbon atomic mass is 12, okay?
Okay, sir.
I will add then, and the atomic mass of oxygen is
A.
see what I have written here, atomic mass of oxygen,
Hmm.
16, right?
Yes.
And we have 2 oxygen. So we will multiply it by 2, right? Mamuna, are you sleeping?
Yes, sir. No, 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 sir.
Ah, so 12 plus 32, we will get 44, right? So this is the way to take out the molecular mass of the any compound. See, if you have forgot these things, there is no issue, but try to remember them and try to revise them. Okay, no problem that you do. I'm not asking you to go and dug out those 11th class chapters, chapter 1. I'm just saying, since we have to use this concept, you have to use these formulas, so try to remember them. Okay.
Okay, sir.
Sana, I'm talking to
Yes.
both of you.
Yes, sir.
Hmm. Okay. So I think because of this tricky question and you have to relate it with the 11th class formula, that's why you are getting some, you know, it is being, burden upon you, right?
Yes, sir.
So,
Uh,
sir, in this question, are they saying that NO is 6 grams?
so actually the question is, so according to this question, now the NO is not is 6 gram per minute. So actually it is NO is we have to convert this in moles. So 6 upon 30. This is actually the in moles per minute. Okay.
Yes, sir.
Okay, yes, sir.
So now we will use this formula. So the formula, the rate of reaction the rate of reaction is 1 by 2 times of rate of disappearance, which we have to find out. Rate of disappearance of NO2 is equal to half times rate of formation of NO is 6 by 30, right?
Yes, sir.
Yes, sir.
So we will, solve this 1 by 5. So the rate of disappearance of NO2 is 1 by 5 in mole per minute. Obviously, the since this was in mole per minute, so we will get the unit in mole per minute, right? Are
Yes,
you
sir.
copying the questions, this solution? I will give you time. Just look here, look over here. Okay. So the rate of disappearance is NO2 is 1 by 5 mole per minute. Till here, are we good?
Yes, sir.
Hmm. So, but the answer we have to take out in gram per minute. Okay. So I think we should, leave it here so that you don't get confused. You take out the question in mole per minute only. So your answer will be this only. Okay.
Yes, sir.
Okay.
So this will be the answer for you. Okay.
Sir, can you show how to then convert it into gram per minute?
Okay. So if you have to remember the formula of moles. So the formula is moles is equal to given mass upon given mass or given weight upon molar mass. Okay. So this one is given 1 by 5 means you have moles, but you have to find, and we always know molar mass of it. You have to find the given weight. Okay.
Yes, sir.
But because per minute will be always there in this question, per minute will be always there. You have to find what is the 1 by 5 moles value, right?
Yes,
Yes,
sir.
sir.
So 1 by 5 equal to given weight. We have to find this upon molar mass of NO2. Now, Mamuna, can you try to, get the molar mass of NO2? Can you tell me? Okay, let me help you. Tell me the nitrogen atomic mass.
14 plus 16 into 2.
14 plus 16 into 2. Yes, this is good. 14 plus, Mamuna, have you understood?
Yes, sir.
Good. So we will get 46, right?
Yes.
So 46. So we will put here 46. So given weight will come 46 by 5. So finally, ROD, rate of disappearance of NO2, is 46 by 5 gram per minute. Okay.
Yes, sir.
Yes, sir.
So 46 into this 1 by 5 is 0.2, right? For 1 by 5 is 0.2. Don't worry. 9.6 gram per minute. Means like 1 by 2 is 0.5 and 1 by 5 is 0.2. So now note it down. Note down the whole thing. Note this down too if you want. Do you want to note this down also? Tell me. This part?
No, sir.
No, sir.
Okay.
Sir,
Hmm.
um, in these questions, we only have to convert gram into mole or mole into gram, but per minute will be there. We don't have
Because
to.
if the question would be per second, then we will have to convert that also. But everything is going in with respect to per minute, per unit time. So we don't have to worry about that.
Yes.
Done?
No, sir.
Okay.
No, sir.
Memuna, where you have got the answer 12?
I used a different formula.
Oh,
That
you have
was wrong.
use this formula only. Miss, this is a
Okay.
one formula only. If anybody have forgot to balance the chemical equation, they will always get a wrong answer. Because examiner will give that thing only. You have to balance it in, then solve it. Meantime, I am giving another question. Try to solve them.
Sir,
Mm-hmm.
this rate of reaction is 1 by 2 into 6 by 30.
Which question? 1
This
by
first
2.
question, rate of reaction.
So what would be the rate of reaction you are asking?
Yes, sir.
Ah, the rate of reaction you are getting is?
No, I mean, we're multiplying this half into 6 by 30.
So the rate of reaction will be 1 by 2 into 6 by 30. Yes, correct. Mole per minute.
So we will get that
Acha,
1 by
that would be another answer you are saying, right? We will
no,
get
so
another.
rate of consumption of NO. It should be 1 by 10 mole per minute. No?
See, actually, now we are not interested in this. In this question, we are not interested with the rate of reaction. I'm giving the next question where you have to find rate of reaction also. So in this, we have just written this, written this formula. However, we don't want this formula. We want only this part of the formula, right?
Yes.
So just forget this one. For meantime, just write this formula. So if you will write this formula only, this half and half, this will be cut, and the rate of disappearance and rate of formation of this will be equal, and you will get 6 mole per minute, which you were earlier getting, right?
Yes.
So you don't have to bother about this rate of reaction just for now.
Oh.
If you want to find rate of reaction, the rate of reaction will be what? This 1 by 2 times this one. This I'm writing this one. Sorry, this. Wait. Rate of formation is giving na. So we will be interested in this formula. So we will write. Let me write for you. Half into rate of formation is given is, what should you want to write? 6 gram per minute or 6 mole per minute?
6 mole per minute.
Yeah, so the answer will be 6. Rate of this will be the final answer. That is it. And the correct way is in mole per minute only. Okay, because we are talking about rate of reaction. So this will be your answer.
So half into 6 by 30 is rate of disappearance.
Come again.
This 1 by 2 into 6 by 30 is the value of rate of disappearance of NO2.
This thing.
Yes, sir.
This actually this is coming because what is this 6 by 30 is moles. So we are getting in.
Converting.
Actually you are
So
getting
it should be 1 by 10, no, sir.
here. This one.
Yes.
6 by 31. 6 5 30. It would be 1 by 5 now. Or this can be 1 by 10.
It'll be 6 by 60 if we multiply.
6 by 60, then it will be 1 by 10. Yes.
Then how are we getting 1 by 5?
This is this is rate of disappearance of NO2, not rate of reaction. Actually, sorry, I don't have. You don't have to write this one. You have to write this much only. Wait. You have to write this much only. That is it. Okay. For rate of reaction, you will get this rate of reaction 1 by 2 rate of formation. Actually, one time you are using mole per minute and another time you are using gram per minute. That is why you are getting confused. Don't worry, when we will do next question na, everything will be sorted out. Okay, don't worry. Okay.
Yes, sir.
Because we are using 2 units, that's why you are getting confused. Don't worry about that. So done.
Yes, sir.
Yes, sir.
Okay. So you have to find out both things. The rate of formation is given, and calculate rate of reaction and ROD, rate of disappearance of B, and the chemical equation which is given is A plus 2B is giving 3C. No, A plus 3B. Solve this question. You have to find the rate of reaction also and rate of disappearance of B and the rate of formation of C. Rate of formation of C is given. Okay, understood the question?
Yes, sir.
So use the above formula, you will get the answer. There will be no confusion.
Sir, we did this question with Salim, sir.
Acha, you have this question.
Yes, sir.
Okay, then try it by yourself. If you are having problem, or look that question. Uh, if you don't want to waste your time. No. Actually, I would like to try it by yourself. We will not solve it here. If you get the answer, if you will have doubt, then we will discuss. Otherwise, we will proceed to next question.
Yes, sir.
Try it by yourself. Mamuna, are you there?
Yes, sir. Yes.
Do this question by yourself. Don't see the solution.
Okay, sir.
Actually, this was a previous year question. That's why it is a little important. So every teacher wants to go through this question. It came in 2020. Actually, this question.
Sir, your voice is not really audible.
Now is it okay?
Yes, sir.
Okay. Actually, this question was asked in 2020. So it was previous year question.
Okay.
That's why teachers do this question for you. Let me know the answers if you got the answer. Done?
No, sir.
Mm,
No, sir.
you're taking too much time. These you have to do this because these are very simple problems, and they will be guarantee, and this is a guarantee that it will be asked in exams, in your this exam also, and in your exam final exams also, in school also. If you are stuck somewhere, you can discuss with me. There is no issue here because we are in learning phase. You may have some doubt, there is no problem. But if you will not ask, how can I help you? Tell me.
Done, sir.
Okay. Memuna, where are you? In
Sir,
the
I'm in the second part.
no,
Almost
I
done.
know you are in class. Means are you in calculation part?
I am in the second part. I almost done.
Okay, okay. So Zaina, do you got the correct answer?
Yes, sir.
Of
Or
both parts?
Done, sir.
yes, sir.
Okay, 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 good. Now, Memuna, have you got the correct answer?
Yes, sir.
So means you have understood the question and solved the correct answer, right?
Yes, sir.
No problem in that. We shall skip that.
Yes, sir.
Now try this question. Then we will, you know, move to the next round of the topics. Have you done this question already? Is this question already done?
No,
No,
sir.
sir.
Okay, then do this, do this. So which chapters are left from your syllabus?
So
Do you,
we have to check.
huh?
So I will check and tell you.
Okay, 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 no problem. I'm just asking. Try to solve this question. Problem. So may I know what step you have taken first, Mamuna? Which step you have taken out first? Hmm?
Rate of formation.
Okay. This girl, Zaina.
Yes, sir. Rate of formation.
Zaina, you written your name in short form, or your name is Zainab?
It's only Zena, sir.
Okay, okay. What is meant of Zaina? Meaning of Zaina?
Um, Beautiful.
Okay, okay. Actually, I want to let you know that first, balance this chemical equation. Balance this first. Balancing is, and let me know that you have balanced the chemical equation. Done balancing?
Yes, sir.
Yes, sir.
Okay, okay, okay. Solve this question. Your time is over, right?
So 4 to 5:30.
Okay, 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 okay. Okay, do this. I have to teach you one more topic also. Just try to solve this. You both have, balance this chemical equation.
Yes, sir.
Yes, sir.
Okay, okay. So may I know what you have done? What is the, coefficient of this N2O5?
2.
2N2O5 gives
Hmm?
4NO2 plus O2.
4 N2O. Yes, good. Now you will get the answer correct if you will find the answer. Solve this.
Alpha into 1000 divided by n.
1.4 into 10 to the power minus. Mamuna, have you got the answer? Mamuna, hello.
No, sir, no. I'm doing it.
So where are you stuck?
Second part.
It has only one partner, rate of disappearance of N2O5. Have you found this?
Yes.
So what is your answer?
0.4, 0.014.
So 0.014.
0.014.
Have you found this in terms of no? I always try to find this in this scientific term, 10 to minus 3. Okay.
Okay.
So so you have also got the correct answer, Zaina. Your answer is correct, and your answer, I think you are getting 1-0 less. Okay. And can you tell me what is the rate of reaction? Mamuna?
Yes, sir.
Hmm?
It's 4.
4. See, so the rate of reaction here will be the rate of formation of NO2 is given. So NO2 is forming. So we will write plus 1/4 times rate of formation, like this. We are going to write, right? You may have written like this, right?
Yes, sir.
And disappearance of N2O5, disappearance of N2O5 minus times half into N2O5. Why I have written minus? Can you tell me? Anybody? Why I have written here minus and here I have written plus? Namuna,
I don't know, sir.
Zana?
Because it's rate of consumption.
Yeah, it's rate of consumption because by time the value of it is decreasing. Okay. That is why we have to multiply it by negative sign. Okay.
Okay,
Mamuna,
sir.
have you understood?
Yes, sir.
Okay. So since the question is not asking rate of reaction, so we are leaving this part. So this will be solved in a minute. NO2 rate of formation is given 2.8 into 10 to the power of minus 3, and we have minus times half into, we have to find this one only. Okay, so we will assume it is as x, so we will cancel this out, this we will cancel out. Okay, 1.4, so the answer will be 1.4 into 10 to the power of minus 3 mole per minute, right? Got it?
Yes.
So I hope you both have got the answer, right?
Yes, sir.
Yes, sir.
Zana, now like for example, the question was asking rate of reaction also. Okay, so see what will I do? 1/4 times this. Am I correct in writing this formula? Tell me, is this okay?
Yes, sir.
So just we will put down the values. The value of this one is given is 2.8 into 10 to the power of minus 3, and we will get 7 into 10 to the power of minus 4, means 0.7 into 10 to the power of minus 3 or 7 into 10 to the power of more per minute. So this one will be the meter per second. Sorry, it will be second. Question is given in second, na? That's why. Got it? Mamuna, any confusion?
No, sir.
Zana?
Yes, sir. Got it.
Achha, you got it. I thought yes, sir. I have got confusion. Okay, so the rate of reaction or rate of disappearance or rate of formation, there will be no confusion. Okay, just solve them independently. If you solve them independently, na, you will not get confused and the answer will be correct always. Okay.
Yes, sir.
Yes.
Acha, since the question is asking rate of disappearance, so answer will be not in negative. If it will be asking uh, rate of N2O5, then you can write with a minus sign. Otherwise, since it is disappearing, this is understood that it is gonna exhausting, so it will be in positive only. Okay.
Yes, sir.
Okay,
Uh,
sir.
and your exam is subjective, so you don't have to worry about it. Now you have to know that this rate of reactions are of two types. Okay, that which we are calculating rate na is of two types. Okay, just introducing you a little topic. This is only like 10 minutes topic, so you don't have to worry. So types of rate of reaction. Okay, so we have two types of rate of reaction. So first one is average rate of average rate of reaction. Okay, and the other one is instantaneous. Do you know the meaning of instantaneous?
Yes, sir.
Can you tell me how? What is the means instantaneous?
A small amount at that particular time, or for instantaneous, we take out delta value since it's a very small amount of rate of reaction.
Is small or very small amount of time at an instant, at
Yes,
exactly at a point of time. I'm asking this thing like rate of reaction or instantaneous velocity, instantaneous acceleration, right? In the physics part, you remember the first time when you have heard instantaneous, right? At the exact moment of time, instant, at that instant, from that instant word, instantaneous word came, right?
yes, sir.
Okay, huh. So now you have to understand these two things. First we will explain average rate of reaction. So what is average rate of reaction? Change in concentration of, you understand these short forms? Concentration, okay?
Yes, sir.
Change in concentration of reactant or product in a fixed interval of time. So change in concentration of reactant or product in a fixed interval of time means here we will take like 2 seconds, 5 seconds, 10 seconds. So what is the rate of reaction like after 10 minutes, after 15 seconds, right? So in a fixed interval of time, with in a fixed interval like in an hour or in 10 minutes or in 15 seconds. Okay, so in an interval of time, not at exact moment of time. Got this language wise?
Yes, sir.
Yes, sir.
Instantaneous instantaneous rate of reaction, and this is, it is the rate that is calculated that is calculated at a particular instant of time. Okay, when rate is calculated at a particular instant of time, just just tell me what is the rate of reaction at that time. Just tell me. So that will be the at the instant I'm asking what is the rate of reaction. Okay, at a particular moment. Got my point?
Yes, sir.
Acha, have you both noted this in this question, rate of reaction?
Yes, sir.
Yes, sir.
Because if you will revise now, then whenever you get confused, just do some questions or compare with the, if you will get the right answer, then it's well and good. Or compare with the solution of that, then you will get, you will be okay that yes, this is how I have done the question. So now, so we will compare what are average rate of reaction, what is instantaneous rate of reaction. Let's draw a graph of it. Acha, by time, what do you think, Mamuna? Reactants are by time. Reactants are increasing or decreasing by time,
Increasing,
and product is decreasing by time.
decreasing,
Uh, Zainab,
Yes, sir.
so product is increasing with time or decreasing with time?
Products are um, increasing with time,
And reactants are?
decreasing.
Are you getting, Mamuna?
yes, sir.
Is product increasing or decreasing with time? Hmm?
Increasing,
Okay. So you were confused earlier, right? So see, let's for example, in this y-axis, we are taking a concentration of reactants. Okay, and with respect to time, we are drawing a graph. Okay, the concentration of reactants will decrease with respect to time. Okay,
Yes, sir.
so we will decrease the concentration rate with respect to time. Okay, so the concentration of reactant is decreasing with time. There is no issue in it, right?
yes, sir.
Yes, sir.
And the product concentration will increase with respect to time. So we will draw the graph in upward direction, right?
Yes, sir.
So initially, the product concentration will be at 0, right?
Yes, sir.
So it is
Yes, sir.
increasing with respect to time, and there is some issue in it because reactant value is known now. We are just taking examples, so it is decreasing with respect to time. So see, so now this graph is clear for you. Okay.
Yes, sir.
So what we are doing in this average, this one I am making about this one average rate of reaction here, and this is instantaneous rate of reaction. This for understanding only. So we are taking some interval of time, like from this interval of time to this interval of time. Okay. For
Yes, sir.
example, 2 seconds to 5 seconds. Okay. So the interval of time is 3 seconds, right?
Yes, sir.
Yes, sir.
So here the this rate of reaction, average rate of reaction will be acha. So tell me this concentration at 2 seconds was this, right? Am I
Yes,
correct?
sir.
Ha. And at 5th second, the reactant concentration has been decreased. Can you see this? This has been decreased,
Yes,
right?
sir.
This value has been decreased from this to this. No
Yes.
problem. So we can say this amount, this is reaction at reactant at initial position, and this at reactant at final position. What is this final initial position? When we are told to measure the value. So when we took out the experiment, we took experiment from the second, yes, and we will complete the our this experiment at 5 seconds. Okay, so the reactant has been decreased from Ri to Rf. Okay.
Yes,
Yes,
sir.
sir.
So simple, Ri minus Rf upon T2 minus T1. This is the rate of reaction. The rate of reaction is concentration upon time, right?
Yes, sir.
Yes, sir.
So this is the delta C upon delta T, the rate of average rate of reaction. Is it okay for you?
Yes, sir.
Yes, sir.
Now we will find instantaneous rate of reaction. R instantaneous. Acha. At R instantaneous, what do you think? You have to draw, if I will give you one task to find the rate of reaction at 10th second, for example. So you have to sit on 10th second. You will go and just sit on 10 second. Okay. You will go and sit on this position. Okay. And this, you will find this product value, right?
Yes, sir.
Yes,
So
sir.
here the, from mathematical point of view, this one and this one, see this in this, check about this, check out this. I have to draw line actually. At this point, you have to see that this is a tangent which is touching this this point, this graph. Okay. Okay.
Yes, sir.
Yes, sir.
So you have to draw a triangle of it and you have to find theta of it. So you will get this delta C by delta here will be dc by dt. When this is very at instant of time, na, as Zainab, you have said that at instant of time, or you can say very, very small moment of time. So we will denote it by small d. You remember, like acceleration, we say dv by dt. Remember acceleration?
Yes, sir.
Or velocity dx by dt. So at a small moment of time. So at a small moment of time, what is the concentration at that moment of time? So we will get this tan theta. This is a mathematical, mathematical way of showing this thing. You draw a tangent on it at that time in the graph, and what the theta you are getting will be the, rate of that. If you, want to remember, like for example, you have this thing. This is velocity versus time graph. If anybody wants to get acceleration at this moment of time, then he has to draw, line across it, tangent across it, and you draw a triangle on it, and this is the theta. Okay, this is actually positive theta, this is actually negative theta. That's why I have drawn this like this. Are you getting this?
Yes, sir.
Actually, this is physics thing. You don't have to uh, you have to understand the concept only, the theoretical thing. I've made you the graph to completely grasp the this thing. So in average thing, you have to take about a interval in an interval of time, and in a instantaneous thing, you just have to look at the instant of time. Okay, Mamuna, you are having some problem, you can ask, no problem.
No, sir. No.
You got this?
Yes, sir.
So you both have understood average rate of reaction and instantaneous rate of reaction?
Yes, sir.
Yes, sir.
Okay. So, Acha, you have any problem in this? I think you have understood all these things. Rate of disappearance, rate of uh, and this rate of reaction, no confusion?
No, sir.
Okay.
No,
So,
sir.
okay. So revise them because these, especially these numericals, these are very important. Not exactly this one, means this one.